late 1980s, Amartya Sen, a Nobel Prize winner in economics, devoted himself to a demographic tragedy little known beyond the academic circles. Sen used sensational headlines in order to convey his message. He was concerned about the shortfall in the number of women in some regions of the world compared to what their numbers would have been if women and men had equal life chances. He attributed this shortfall to pervasive discrimination against women. In the U.S., we often think of discrimination in terms of low wages and limited opportunities, but in some countries, it is a matter of life and death. This issue has come to be known as the problem of missing women, an important topic in the field of demography. In this program, we apply statistical research methods to study this issue. Discrimination is a difficult topic to study because it is hard to measure directly. The population sex ratio provides an indirect indicator of discrimination. This measure is usually reported as the number of males per 100 females in the population. If discrimination is severe enough to cost lives, then it should show up in the relative number of females and males in the population. Here we show how the tools of correlation and regression can be used to explore the social factors connected to the shortfall of females in the population. We find that we cannot really understand the missing women phenomenon without considering multiple causes. At any given point in time, the sex ratio of a given geographic area reflects the net result of differences in the number of births and number of deaths of women and men, and of the numbers migrating in and out of that area. Demographers have found that about 105 to 106 boys are born for every 100 girls. That is a sex ratio of 1.05 or 1.06. This is viewed as the normal population sex ratio at birth and is generally observed around the world. The slight imbalance in favor of boys could be a biological adaptation stemming from the fact that boys are genetically more susceptible to death from illnesses in infancy. The natural tendency is for the imbalance to disappear by about age 5. As boys and girls grow up, however, many social phenomena affect the sex ratio. Where access to modern medical care was, and still is, scarce, complications during pregnancy and childbirth reduce the number of women in the population. In the modern era, however, if men and women are provided with equal care, women have longer life expectancies than men, and this should result in a lower overall sex ratio worldwide. Historically, wars have resulted in a shortfall of men. Migration is another factor that influences the sex ratio. Often men migrate in larger numbers than women. As a result, the countries and towns receiving the migration have a high sex ratio. This was the case in the towns of the American West in the last century. It can still be seen in industrial and mining towns and developing countries today. The counterpart of male migration is a low sex ratio, that is a shortfall of men, in rural areas from which men migrate. Thus, the sex ratio of a country reflects the net result of a host of influences on the conditions of life of females and males within its borders. This map of the world is shaded to illustrate the regional differences in the sex ratio. These ratios are calculated from the United Nations statistics. In 1995, there were slightly more women than men worldwide. The world sex ratio was 0.99, or in other words, 99 men for every 100 women. Notice the significant regional differences on this map. The ratio is particularly low in the former Soviet Union, and it is quite high in the Middle East. The low sex ratio in Russia, which is 0.88, has been widely attributed to the poor health of Russian men caused by their heavy smoking and alcohol use. Their unhealthy habits are said to lead to higher death rates in the context of declining availability of health care after the breakup of the Soviet Union. In Cambodia, the civil war and genocide during the period of the Khmer Rouge regime can be seen in the quite low sex ratio of 0.94 in 1995. If we turn to West Africa, we can see the effect of massive male migration into Cote d'Ivoire in this country's relatively high sex ratio of 1.04. This immigration is associated with economic development and political stability in Cote d'Ivoire that contrasts with the state of affairs in the rest of the region. At the other extreme are the very high sex ratios in the Arabian Peninsula, followed by the relatively high sex ratios in the world's most populous countries of China, India, and Pakistan. Social scientists have interpreted the shortfall of women in these countries as evidence of discrimination severe enough to result in high female death rates. Since so many factors can be at work in determining the population sex ratio, in order to study the effect of discrimination on the relative life chances of females, researchers often focus on the sex ratio among children. The presumption is that boys and girls are either unaffected or equally affected by conditions of war, migration, and other events. Girls and boys are equally likely to accompany the migrating adult or to stay with the parent left behind. Children are too young to die in wars or civil violence, and they are obviously too young to die from alcohol abuse or complications of pregnancy. So when researchers find a shortfall of girls compared to the numbers expected for a given age group, they see this as indirect evidence of discriminatory practices against girls. The cross-country differences do not seem very large, ranging from about 0.9 to 1.1. Is this much ado about nothing? Sen claims that 100 million are missing. This is a huge number. However, with 6 billion people in the world, a shortfall of 100 million women only raises the ratio from 0.99 to 1.02. This shows that relatively small changes in the observed ratio involve relatively large numbers of lives. A discriminatory shortfall of girls in the population can be attributable to 3 human-made causes. Fewer girls are born, some of those born are killed, and some die because they are not adequately cared for. The most extreme form of discrimination is the practice of female infanticide, the killing of baby girls soon after birth. Infanticide has a long history, and although it continues today, it is unlikely that it can account for the observed 100 million shortfall of women highlighted by Amartya Sen. The modern version of infanticide is the practice of aborting female fetuses after determining their sex by an ultrasound test. Sex-selective abortion has become alarmingly prevalent with the increasing availability of modern medical technology in South and East Asia. Perhaps the most likely cause of the shortfall of girls is discrimination against them in the allocation of care and family resources. For example, girls are more likely to die in infancy if they are provided with less food or health care than boys. Such discriminatory practices are no doubt connected to a cultural preference for sons. Sons continue to be more valued than daughters in many cultures in South and East Asia and the Middle East, the regions where the world map indicates a shortfall of females. In China, people congratulate parents on the birth of a child much as they do in other countries. However, they refer to a new daughter as a small happiness and a son as a great happiness. In rural India, when a man asks another about the number of children in his family, it is commonly understood that he is asking only about sons. In addition, he may also ask, "Any daughters? Why might sons be more valued than daughters?" One reason is the economic reality that sons can bring greater returns to their parents, either in the form of wage earnings or in their ability to work on the family farm. Young men have more earning opportunities because, unlike young women, there are fewer restrictions on their ability to move, mingle, and work among strangers. In Bangladesh, for example, young women traditionally are permitted to take employment only on farms bordering their home. If the family's crop has been harvested, only men can transport it to the market, and only men can negotiate its sale. These restrictions on employment and job duties effectively limit women's economic contributions to the family. In addition, in kinship systems where daughters are absorbed into their husband's family, sons are more likely to support parents in old age. In the absence of public support for the elderly, such as Social Security, having a son is the best retirement strategy for parents. What's more, girls can be a financial burden on parents where the practice of dowry is common. In northern India, for example, a father has to make a cash payment to the groom's family upon his daughter's marriage. Dowries are symbolic of the perceived lack of economic contribution by women. The daughter is a cost to her father, and the groom's family needs to be compensated for the economic burden they take on. In studying the problem of missing women, we are faced with a social phenomenon that is difficult to study. Individuals practice discrimination, but we cannot easily observe this. We can see only its consequence, a high sex ratio, averaged over large numbers of people. This high ratio is observable, while discrimination itself is not. Amartya Sen interprets high sex ratios among children as indirect, yet strong evidence of discrimination against girls. But how do we know if the alleged discrimination occurs on a scale large enough to cause the 100 million shortfall of females? We can't. And how can we know which practice is the most important contributor to a high sex ratio? Is it sex-selective abortion, infanticide, or inadequate care? Given the legal and moral sanctions against killing, it is impossible to obtain statistical information on female infanticide. Sex-selective abortion and differential care are difficult to quantify too. Parents rarely admit to giving inferior quality of care to their daughters. Thus, it is hard to quantify the relative contributions of such practices to an observation of a high sex ratio. How can we know what we can't see? Here's how. A high sex ratio among newborns is clear circumstantial evidence of the practice of determining the sex of the fetus and aborting female fetuses. The prevalence of this practice is obvious in some parts of the world. For example, in the last decade, prenatal sex determination entrepreneurs have flourished in India. They tout the cost savings of prenatal sex determination. The vans equipped with ultrasound machines reach the remotest villages. Their advertisement proclaims, better 800 rupees now for an ultrasound test than tens of thousands of rupees later for a dowry. How widespread is this practice? Let's look more closely at the statistics. As you will recall, the normal sex ratio at birth is about 1.06, that is 106 boys for every 100 girls. It has been observed recently that the sex ratio at birth for the second or third child is significantly elevated in a number of Asian countries. In China, for example, the sex ratio observed for the first child is 1.06, but it jumps to 1.21 for the second birth, that is 121 boys to 100 girls. When their first child is a girl, many couples try to ensure that their second-born is a son. They guarantee this by resorting to sex-selective abortion. Sometimes government population programs have unexpected side effects. Son preference is no doubt heightened by China's draconian one-child policy. This policy, begun in 1979, provided incentives for one-child families and penalties for additional children. It has since been revised to allow 2 children per couple if the first is a girl. The result of this policy is not only fewer children, but also fewer girls. In South Korea, too, the sex ratio for third births jumps to 185 boys per 100 girls. In this case, couples choose to have fewer children rather than being forced by government policy. This extraordinarily high ratio suggests that many couples are terminating a third pregnancy if the fetus is a female. This evidence shows that discrimination against girls is not a thing of the past, and rather than disappearing under the influence of modernization, it is practiced with renewed vigor. How could we determine whether discrimination against girls is at work in the allocation of parental care and financial resources in the family? A variety of quantitative and qualitative evidence helps evaluate this possibility. In countries where death statistics are reliable, the prevalence of higher death rates among girls compared to boys provides more direct evidence of discrimination than the population sex ratio. In this case, the mortality sex ratio may be used either along with or instead of the population sex ratio. Unfortunately, death statistics are not very reliable because often female deaths are underreported. Indirect quantitative evidence of discrimination is found in health statistics. These may reveal less food consumption, greater degree of malnutrition, stunting, and ill health among girls. For example, a study in Bangladesh found that among children under the age of 5, boys consume 20% more calories than girls. Similarly, statistics on the use of health care facilities may show that sons are more likely to be brought in for medical care than daughters. For example, the same study found that girls suffering from diarrhea were half as likely as boys to receive medical treatment, although this treatment was available free of charge. This study also determined that Bangladeshi girls and boys were equally likely to suffer from diarrhea. Fertility statistics can also be a source of information on discrimination. If they indicate that women whose first child was a girl end up having a larger number of children than those whose firstborn was a boy. In rural Turkey, for example, women who first had a son, followed by a daughter, had a total of 5.3 children on average, compared with an average of 5.5 children among women who first had a daughter and then a son. Qualitative data also provide invaluable complementary information on discrimination. The folk idiom that girls are a small happiness is a good example of this. In addition, the prevalence of popular beliefs justifying the reservation of higher quality foods for sons reflects differential care given to boys and girls. In the Indian state of Uttar Pradesh, for example, parents often withhold nutritious foods such as butter, milk, and meat from girls because it is believed that these foods would hasten the onset of puberty in girls. This rationale appeals to parents who are anxious to protect the sexuality of their daughters. In other parts of India, giving richer foods to boys in the winter is justified by the folk wisdom that girls have a greater capacity to withstand cold and suffering. Such presumptions about different needs of boys and girls may make discrimination acceptable to mothers and can kill their daughters. Thus, a researcher can use one or more of these pieces of household-level data to infer that the shortfall of girls in the population indicates discrimination against girls in the allocation of household resources. While certain countries in Asia have high sex ratios nationally, the within-country variation in sex ratios suggests that discrimination is not uniform. India, with its high sex ratio and a tradition of son preference, has been studied extensively. This map of India shows the definite contrasts and regional clustering in the relative chances of survival of young girls. It shows that a high sex ratio among 0 to 9-year-olds is a characteristic of the North rather than the entire country. Likewise, this map shows that in northern India, among 0 to 4-year-olds, girls die at much higher rates than boys, while in the south and coastal regions, the opposite pattern prevails. Researchers have linked this pattern to regional differences in kinship structure and the economic value of women. Patrilineal kinship traditions are strong in the North, where sons are strongly preferred. In this system, daughters marry out of their parents' family and into their husband's family, usually in another village or town. Fathers are expected to provide dowries for their daughters. In addition, the type of farming that is prevalent in the North does not rely on women's labor. By contrast, in southern India, patrilineal family traditions are weaker. Dowry is virtually non-existent, and women play a prominent role in agricultural production. India provides a clear example of how regional differences in economic and cultural tradition is directly related to the regional contrasts in the sex ratios. The Indian case also underscores the fact that country-level averages conceal the diverse patterns within a country and cautions us all against making sweeping generalizations about national character on the basis of one regional pattern. Building on the conclusions of the Indian studies, two economists at the University of Utah, Gunseli Berek and Cihan Bilginsoy, have been studying discrimination in Turkey, their native land. Turkey is not known for its shortfall of girls. The overall sex ratio is 0.98. This means that across all ages there are more Turkish women than men. Since the overall sex ratio is influenced by a variety of factors, however, Berek and Bilginsoy have examined data on the sex ratio of children. For the 0 to 9 age group, the sex ratio in 1985 was 1.05. When compared with a demographic benchmark for this age group of 1.04, this does show a small shortfall of girls. As often happens, however, the average ratio conceals wide variations across provinces and a distinct geographical pattern. The sex ratios are lower in the west and north of Turkey and higher in the east and south. The ratio ranges from a low of 1.01 to a high of 1.12. As we have seen, this is a rather wide variation for this statistic. This variation prompted Berek and Bilginsoy to look into its causes. Interpreting a high sex ratio among children as an indicator of discrimination against girls, they sought to determine the causal factors that explain the variation in the intensity of discrimination. Since they did not have direct evidence on the extent of discrimination, they attempted to identify province-wide characteristics that could have a bearing on the severity of discrimination in the family. The indirect logic of this research can be illustrated with a diagram. Berek and Bilginsoy explored the statistical correlation between two sets of variables for which they could obtain data: province sex ratios and a set of province characteristics that they thought were likely to affect the sex ratio via the unobserved discrimination process. This is shown in the lower half of the figure. Statisticians have a name for broad indicators of this sort. They are called proxy variables. In this case, they are proxies for discrimination. This term indicates their indirect nature. Using data for 76 provinces, our researchers tried a variety of proxies in their search for an explanation of the sex ratio. As proxies, they used 2 indicators of development and 1 for job opportunities. Eventually, their statistical analysis led them to tentative inferences about the factors that intensify discrimination and cause higher death rates among girls. This is shown in the upper half of the figure. Their first proxy is the gross domestic product per capita, also known as GDP per capita or income per capita, which is the most commonly used statistic of economic development. The missing women problem is often thought to be the outcome of underdevelopment. Some experts argue that discrimination against girls becomes an economic necessity when resources are scarce, and that a rise in the income level reduces discrimination as more resources become available for the average family. If this theory is true, they should find an inverse relation between province income levels and sex ratios. The average income level shows considerable variation across Turkish provinces. The correlation coefficient between GDP per person and the sex ratio among 0 to 9-year-olds is minus 0.33. It would appear that the economic development hypothesis is supported by the Turkish data. In more developed provinces, there is less discrimination against girls. This can be seen in the scatter diagram. Some think that a high average income level is a poor indicator of either the resources available for the typical family or generalized economic development. Amartya Sen, for example, explains that development should be viewed as a process that expands basic freedoms of people. Freedom from hunger, freedom to live long and healthy lives, freedom to seek knowledge and enjoy their culture. In this view, a higher income per capita may be a means to greater freedom, but it does not guarantee this. Sen's conception of development is better measured by educational or health indicators of availability of schooling or health care. Thus, Barrick and Bilgensoy add women's literacy rate, that is the number of literate women divided by the female population, as an alternative indicator of development in this broader sense. No doubt literacy measures access to schooling. One way this proxy may affect discrimination is that women who are literate learn to provide more equitable care for sons and daughters. If these effects improve the survival chances of girls, the result would be manifest in a negative correlation between women's literacy rate and the sex ratio. Barrick and Bilgensoy find a strong inverse correlation with a coefficient of minus 0.73. This relationship is shown in this scatter diagram. Another proxy variable suggested by the studies on India is the female labor force participation rate, defined as the fraction of women who are in the labor force. Compared to the first 2 variables, this variable is more directly linked to the value the society places on women, and therefore linked to the treatment of girls. As Barrick and Bilgensoy explain, the greater the economic contribution of daughters, the larger their command over household resources, and the greater their chance of survival. Given this expectation, they were a bit surprised to find that the correlation coefficient between the female labor force participation rate and the sex ratio is in fact nearly 0. The scatter diagram shows no relationship between the 2 variables. Nonetheless, our researchers wanted to test this hypothesis in a multivariate framework. A good way to disentangle the separate effects of multiple causes is multiple regression. This method, as you should remember, fits an equation through the data in multiple dimensions. In this case, Y is our dependent variable, the sex ratio for the 0 to 9 age group. The X's are our proxy variables, GDP per capita, literacy rate, and labor force participation rate. The betas are the coefficients to be estimated, and the epsilon is an error term. This is our empirical model of the determinants of discrimination against girls. How well does it work? Here is the estimation result. A computer program estimates 4 parameters, the betas. Ignoring the first, which is the constant term, the second parameter, the 0.001, shows virtually no relationship between the proxy, GDP, and the dependent variable, the sex ratio. The third and fourth parameters, the minus 0.116 and the minus 0.052, show that both women's labor force participation and female literacy rate have a noticeable negative effect on the sex ratio. It appears that when all 3 indicators are taken together, the results differ from those obtained in our earlier exploration of the bivariate relationships. Now the labor force participation effect becomes important while the income effect disappears. The formal test of the income hypothesis confirms this impression. That is, we cannot reject the hypothesis that beta 1 is 0. In other words, we cannot reject the hypothesis that the income effect is absent. The researcher might summarize these computations by saying that the literacy and participation effects are statistically significant, whereas the income effect is insignificant. Closer examination of the labor force data indicates that women's participation is higher in less urbanized provinces where farming is the major economic activity. In turn, the regression results suggest that the value of daughters as laborers on the family farm is an important force that reduces discrimination against girls in Turkey. But women's literacy is also lower in these less urbanized provinces, and a lower literacy rate is correlated with greater discrimination against girls. The regression suggests that the two variables have opposite yet independent effects on the sex ratio, an economic worth effect and an education effect. In this program, we examined how social scientists use statistics to study social phenomena that are only indirectly measured. Barrick and Bilgensoy would love to have a better measure of sex discrimination than the mere counts of boys and girls, but they don't. They can only guess at the details based on the statistical association of proxy variables. When dealing with proxies, we should always be careful not to overstate our research conclusions. Our inability to directly observe discriminatory practices within households and our reliance on province-level proxy variables limit our inferences. The stronger the complementary household-level evidence on discrimination, the stronger the inferences based on such a study will be. Scientists would also prefer controlled experiments, but in most social sciences this is impossible. We can only examine real societies where phenomena are influenced by multiple factors simultaneously. In this situation, multiple regression is a powerful tool for the study of society. Our regression for the Turkish case helped us identify the net impact of a host of factors on the sex ratio. Multiple regression suggests that a girl's survival chances are better in provinces where women's labor force participation rate is higher and where a higher proportion of women are literate. It also shows that a higher level of prosperity per se does not have much effect. Based on this analysis alone, one cannot reach precise conclusions about how discrimination intensifies or weakens in the family. To do the latter, Barrick and Bilgensoy plan to pursue a household-level analysis. Any research project that aims to explain an outcome of discrimination must draw upon multiple sources of data and methodologies, quantifiable and qualitative. Despite these qualifications, multiple regression with proxy variables plays an important role in understanding the troubling problem of missing women. Thanks for watching.